All right. Welcome again to Friday morning. Starting off here in track two, we've got Andy Robbins, also you may know him as Waldo, attacking and defending Azure with BloodHound. Andy is one of the co-creators of BloodHound and is the product architect of BloodHound Enterprise at SpecterOps. His background's in red teaming and pen testing. He's written about Azure attack primitives on the SpecterOps blog, spoken at and given training at conferences all over the place for Active Directory security. So he is the guy you want to hear about BloodHound from. All yours.
Thanks. All right. So there's a couple empty seats in the front right here if you want a front row seat, premium first class. So thanks for that intro. Like you said, this is attacking and defending Azure with BloodHound. If you're a web app person, you're in the wrong room. So we've already said all this, but if you want to see a higher resolution of my face and maybe see some of my pores, there's a higher resolution version of my face. You can find me on Twitter at _Waldo with a 0. So here's the agenda for what we're going to be talking about, and we've got a lot of stuff to go through, and so I'm going to try to go at kind of a fast clip. First, we're going to talk about what problems we are trying to solve by using graphs to attack and defend Azure. Then we're going to look at attacking Azure, then defending Azure with graphs, more specifically with a graph tool called BloodHound, and then a conclusion at the very end. So I'm going to start off by getting on a little bit of a soapbox and talk about what problems we're solving. But I want to do this to frame the context of why we use graphs in the first place, because a lot of times things can turn into a solution in search of a problem. But I want to try to explain how this is a solution that is solving a very specific problem instead. So first of all, I want to talk about where we've been. In the room, is anybody in here like a pen tester, red teamer, like IT audit, something like that? Okay, and then what about on the defensive side? Okay, so there's like way more defenders in here than attackers, I think. So I'm going to tell you where we've been as far as the offensive side. And for the defenders, you may be familiar with some of these tools. Active Directory launched in 1999. And it wasn't until 2007 that we had a toolkit that could actually abuse the pass the hash primitive. So pass the hash actually came out way before this, but it wasn't until Hernan Ochoa put out the PTH toolkit that it was actually usable and reliable. So what is that? That's 8 years after the initial release of Active Directory. After that, we get Mimikatz a full 12 years later. Responder Kerberos from Tim Medine. Tim is at the Red Siege booth. If you've ever used Kerberos, you owe him a beer or a beverage of his choice. And then in 2021, 22 years, or what you might call like a whole generation of people after AD first came out, we had the ADCS abuse primitives formally documented and understood and, let's say, weaponized. So that anybody can pull a tool off the shelf and audit for misconfigurations in a real environment regarding Active Directory certificate services. So what do all these tools have in common? They don't exploit anything. They abuse configuration issues, but they're not taking advantage of anything that Microsoft can patch or that Microsoft will change because of the backwards compatibility issues with supporting legacy Windows installations. So they abuse legitimate protocols. There's nothing for Microsoft to patch here. This is all about misconfigurations. And finally, what they all have in common is that they are extraordinarily reliable. I might even say that some of the offensive tools that are out there are more reliable than some of the commercial tools that people pay a lot of money for. Mimikatz works basically every time. Like if you've rolled the binary for the correct version of Windows, it is going to work. And the fact that software is free and that it's basically developed by 2 people is incredible. It's absolutely incredible. So that reliability is not about the tools themselves. That reliability, it reveals the extreme reliability of attacking Active Directory. So, like I said, AD came out in 1999. We're still talking about it. Like the Matrix came out when AD came out. We're not talking about the Matrix anymore. We talk about Active Directory still today, and I think that's somewhat unique to AD. But what I will also say before we move on is that the underlying issues that these tools are abusing have more to do with how difficult it is for an AD admin to get AD into a secure posture and maintain that secure posture. And that has to do with the fundamental building blocks of role-based access control that the new identity and access management platforms like GCP, AWS, Azure AD, and Okta are also built upon. They use the same building blocks. So where we've been with AD, if things don't change, is where we will be in 10 or 15 or 20 years with AWS and Azure AD. So Amazon and Microsoft, they have not fixed these underlying issues with the fundamental building blocks of how RBAC works. In short, for over 20 years on the offensive side, we've been using the same TTPs to reliably take over any enterprise running Active Directory. Last thing I'll say here is if you're a consultant and you are delivering a report to your customer and you find yourself writing up the same exact findings over and over and over and over and over and over and over, you have identified an industry problem, not a customer problem. So zoom your perspective out a little bit and stop criticizing customers for things that they can't fix. Where we are today. So for the red teamers in here, you might find this kind of familiar. Somebody hires you to do a red team assessment or a pen test. You find and execute an attack path to go from no access all the way up to domain admin, let's say. You deliver a report and your customer remediates either none, some, or all pieces of that attack path. They hire you the next year and you do it all over again. And a lot of times you wind up writing up the same exact findings year after year after year. And that gets kind of boring after a while. But what about from the defensive perspective? I think this is actually a pretty easy thing to project. So the red team, the jerks that we hired to come tell us how much we suck, came in, showed us some new attack path that we had no idea about through no fault of our own. Like, these are very hard things to find. We try to clean up some pieces of that attack path, and then we run into federated IT, shadow IT, like business requirements, technical limitations, backwards compatibility issues, like you name it. Like, there's so many hurdles that are legitimate hurdles that people try to overcome, and more often than not are defeated by those hurdles. Some time passes and we do it again. So this is frustrating. And in short, I would say that where we are right now is we're tail chasing. We're chasing our tails. We're fighting a war against attack paths with the wrong weapons. So I come from pen testing like banks and credit unions, and it was like week after week after week after week. It was like a pen test puppy mill that I came from. And we would find like one attack path or two attack paths, or if you're a rock star, you find 3 attack paths in that network. We started doing things on the defensive side with BloodHound, and we started actually counting out the total number of attack paths that actually existed in like a decently sized network, let's say 10,000 endpoints. And it's not like dozens, it's not hundreds, it's not even thousands, it's literally tens or hundreds of millions. So finding one attack path per year, forget it. It's the wrong tool for the job. Where we are going, so now I get to prognosticate to you. So we looked at this before. This is the timeline of Active Directory and the offensive tools that are very popular and very reliable to use against that. Here's Azure. Azure came out in 2008. 2018, we got Microburst from Carl Fossen. 2020, we got PowerAzure from Ryan Hausnecht, StormSpotter from Laurent Gray, and Road Tools from Dirk-Jan Malema. So what is that? That's 12 years after the Azure launch that we like now start to have some formalized, you could say like offensive code, but really offensive code is all audit code. So you can use these things to audit for misconfigurations in your environment. The next 10 years, if we can compare to where we have been with on-prem Active Directory, I would say, and I would project that the most, let's say, effective, maybe we could say devastating tooling around Azure is still to come. We haven't seen it yet. And I would say the same thing is probably true with AWS. I'm not an expert with AWS, but I would say it's probably the case. So where we're going, nobody really knows. Like if somebody tells you they know what the future holds, they're trying to sell you something, right? So the truth is no one really knows. But with that said, let me sell you this. I think this is so true. And this is, if you've ever seen a talk that I've given, you have seen this quote so many times and you're probably tired of it and it's kind of a meme, but it is so true. So John Lambert at Microsoft said, defenders think in lists, attackers think in graphs. As long as this is true, attackers win. I think John should get like a royalty whenever I say that, you know? But anyway, John is totally right about this. He has a blog post written up about like what exactly he means by this. This is the idea that I want to sell to you during this talk, that if we continue to do things the way we've done for the past 20 years with on-prem AD, in on-prem AD and in other platforms, that we're all going to be here in, what year is it now, 2022? We're going to be here in 2042 talking about Responder and Mimikatz still. And I think that would be a huge shame. All right, let's look into some cooler technical stuff. I think we're doing pretty well on time. So we're going to talk now, we're going to switch gears totally. So we're going to get like way more technical now, and I'm off my soapbox for now. We're going to look at an attack path that starts off with no access into an Azure tenant and escalates all the way up to global admin by abusing configurations that we commonly see in real customer environments. And what is very common, if you follow all of the best practice guidance, all the documentation, like here's how you set this up, these things chain together, and we're going to see exactly how those chain together to create this attack path. Our first step is we're going to get initial access into the Azure tenant through OIDC. Does anybody know what OIDC is? OIDC is Open ID Connect. And so this is a way to federate one-to-one identity from a identity in your Azure tenant to an external thing. And for this particular use case, that thing is a GitHub repository. So we have a video to look at together. And I'm actually I'm gonna do this because I do want this to be full screen. And you should be able to see that okay. So in our attack path, we have compromised this GitHub organization. And let's just agree that we've done that. Let's not argue about how that's done. Let's just all agree that that happens. And after we compromise that GitHub organization, we look through the various repositories to find this repository, which has a GitHub Actions YAML file in it. Is anybody familiar with GitHub Actions? GitHub Actions are really cool, and they let you do things automatically whenever something happens in the repository. So say, for example, whenever you make a push to the repo, this GitHub action will start an ephemeral virtual machine that can do things like it's Bash or PowerShell or whatever. Like anything you can do in Bash or PowerShell, you can do. You can assign identities to those ephemeral virtual machines so that the GitHub action has privileges to do things. That's never gone wrong, right? Giving arbitrary objects identity. So in this YAML file, like we're the attacker, we have found it in this state. And what is it doing? If we look at the very bottom, there's a command where it's running azad group list. So it's this totally innocuous script. All it's doing is enumerating the security groups from the Azure AD tenant. We have the tenant ID there, and we also have the client ID. So that's the object ID or the app ID of the service principal, AKA the enterprise application. And if you're confused yet, I was too. We can change this thing, which you just saw. And the change that I made is using the AZ binary. Instead of listing out the groups, I am having it print out the token for the service principal. And you also may have noticed that the the YAML file is not providing any kind of credential to authenticate as the service principal. That's because of that OIDC trust to the service principal in Azure. So this GitHub action is trusted to authenticate as that service principal without knowing that service principal's password. It's really, really cool. It means you don't have to store credentials in this YAML file. But what happens is if you look at this output right here, it says access token ****. So from the attacker side, that kind of sucks because I want that access token so that I can do things, outside the context of this runbook as that service principal. But GitHub Actions will automatically try to censor anything that it sees as like sensitive data, including Azure JWTs. However, remember I said earlier that this is all just Bash. So we can do all kinds of really fun things in Bash. And one of those really fun things is we can pipe strings to other binaries. And we can also chain commands with a semicolon character. This is like IT95. It's like remedial IT stuff, right? So we will edit this again to base64 encode the output from the AZ binary, assign that to a bash variable called token, and then echo the token out. We'll let that run. This should speed up, yeah. So it's running, it's doing its thing. We look at the resulting output. We have some base64 blob here to look at. We'll copy and paste that and decode it. And there's our JWT. Easy. So that's like a nice, easy bypass around like GitHub's automatic, what would you call that? Obfuscation of secrets, I guess. So that's fun. But what's even more fun is we can take that JWT and now from our own attacker-controlled system, we can authenticate to the Azure tenant as that service principal because we have that bearer token. So we have a very simple PowerShell command here that is doing a invoke web request against a particular API, and we're just listing out the service principals, and we're filtering on the first service principal that came back. And so this is just proof that we are authenticated as that service principal. That is our initial access into the Azure AD tenant. Any questions about that? Let's continue. So our attack path so far looks like this. We compromised the GitHub organization in the top left. There's a hierarchical relationship from that org through the repo to the action, meaning that anybody who controls the GitHub org can control the action. That's just hierarchical control. It's easy. And then the yellow arrow is the OIDC connection that goes from the GitHub action to the service principal A in the Azure AD tenant. There's our initial access. So next, we're going to look at something a little more complicated, which is going to be privilege escalation to subscription owner. Let's escape, play, and full screen. So now we are going to use BloodHound to do some analysis. And with that service principal, I'm going to skip this step where we're doing the data collection with Azure Hound because there's a big refactor of Azure Hound coming. And I don't want to show you the old Azure Hound in this, but we've done data collection by using that JWT to read a whole bunch of data from Azure. We take that, we put it into the BloodHound database. The BloodHound database is a graph database. And so we can start to explore relationships between the disparate nodes in that database. So this is the BloodHound GUI. We're going to search for the service principal that we were authenticating against the Azure tenant as. And we were authenticating as the service principal called OIDC connected app. And we know that because we can authenticate and we can read and we can see the display name through the API. We also now know that the OIDC connected app service principal has the cloud app admin role scoped specifically to another service principal called Azure Deployment Automation. So this would be a configuration that the target environment has already set up. We're not like exploiting anything. We're abusing existing configurations. So first, we're going to use our JWT that we got from GitHub. We're going to search for the target service principal, and here's the output that we get back. So up here at the top, that is the unique identifier for the target service principal, which we need for the next step. Because we have the Cloud App Admin role scoped against the other service principal, that gives us the power to add a new credential for that target service principal. So we're not resetting a password or changing a password, we're adding a password. And service principals and apps in Azure can have multiple credentials that are all valid. So we just did that. We just posted our super legit secret, trust me, I would never lie to you secret to that target service principal. Then when we look at the output of that object that we associated with the web request, we have the plain text value of that secret right here. So now we have a plain text password for that target service principal. That means that we can authenticate now as that service principal. That's great. So that's what we'll do. We'll authenticate as that new service principal, and we'll look and see that we now have a new JWT. Some people say JOT as that target service principal. Again, we will do data collection using Azure Hound. Now, we're kind of flying blind. The first service principal we had didn't have any read access into Azure Resource Manager services. So it couldn't see anything beyond the Azure AD tenant level configurations. We do data collection again with this new service principal, and we discover that this new service principal has I think it's owner against the subscription. Yeah. So it owns these, this subscription. And in Azure Resource Manager, these role assignments always inherit down to all descendant objects. So that means that the service principal B not only owns the sub, it also owns the resource group, it also owns the logic app. And as an Azure admin, you cannot change that behavior. So anytime you set a permission on a parent object, it will inherit down below every single time for probably forever. Now we know the rest of our attack path. So let's look at the final leg here, which is going to be privilege escalation to global admin. Now, there's a problem here. So yesterday I was getting ready for this talk and I was setting up the lab environment to actually create these videos for y'all. And what I want to say? I want to say that there's things I can't say about this attack path right now because there's an MSRC case open for something in this image, let's say. So I can't show you one piece of this. Unfortunately, I apologize for that. I've never had to play this card before. It feels kind of weird, but let's just all agree. Let's all agree that service principal B through the blue, white, and yellow lines has been able to create a new credential for service principal C. Can we all just agree on that? We'll just hand wave that for now. Is that okay? Okay. So now the rest of our attack path, now that we are service principal C, is the BloodHound application knows how to analyze like MS Graph permission role assignments. And it will analyze those app role assignments, and then it will create these abuse edges or these abuse connections that we call this post-processing. So service principal C has the MS Graph app role assignment of service principal endpoint.readwrite.all. Is anybody in here familiar with MS Graph? Few people. Okay. Did you know that the service principal endpoint.readwrite.all app role lets you create credentials for any other service principal? It does. So because service principal C has that MS Graph app role assignment, it can create a secret for any other service principal, including service principal D. Service principal D has the MS Graph app role assignment called, bear with me, app role assignment dot readwrite dot all. That app role assignment dot readwrite dot all means that that service principal D can grant itself or other service principals any other app role for any resource app. Does that make sense? Basically, service principal D can give itself any permission it wants. So it's not a global admin, but it can get there. Would you call that a privilege escalation? Maybe. It's actually, I don't think there's really a clear answer to that. So let's hop back into the BloodHound interface, and we're going to see the exact same attack path. Has anybody ever heard of a very very niche, very not very well-known piece of software called Google Maps? Has anybody ever heard of that? The BloodHound GUI behaves very similarly to Google Maps. So in the top left, I've got an origin and I have a destination. So I'm saying I want to start at the Azure Deployment Automation Service Principal, and I want to end at the Azure tenant. So I want to end with full control of the Azure tenant. The GUI will do the query against the database in the backend, and then if there is a path, it will produce it and it will show it to us. So we're looking now at the same path that we were looking at in the deck. So Azure Deployment Automation owns the sub. That inherits down to the logic app. The logic app has a managed identity assignment up to a service principal back up in Azure AD, back in the control plane, if you will. Azure SP Creator can add a secret to app role assigner. App role assigner can grant app roles, and that means that it can take control of the tenant. And we're going to see how that works. There's a really cute elephant. Like I said, we're going to skip part of this. We're going to skip the logic app part of this. And so we have our token running now as service principal C. Then we're going to read from the MS Graph enterprise application, also known as service principal, also known as first party app. And we're going to read the app roles that are exposed by that application so that we can see the identifier for the role management.readwrite.directory role. And you can see that there on the left, the app role ID 9E3F62, whatever. We're going to give service principal D the role management.readwrite.directory app role. So we've done that now. Now it has that app role. Then we're going to read from the Azure AD admin role scope. What is the ID for the global admin role? And so we'll do that. And we get the role template ID, which is actually going to be the same in every tenant, which is 62E9, et cetera. Then we need to refresh our token because whenever you submit a query through MS Graph API, it is like semi-stateless. So the JWT actually contains what roles you have in that JWT. It's way more complicated than that, but let's just agree that we have to refresh our token so that our new token has the role management.readwrite.directory role. Did I lose anybody yet? This took me months to understand. So if you're lost, it's okay. And now we have activated service principal D into the global admin role. At that point, our attack path is concluded. And as a global admin, you can do anything. You can do anything you want. Also, today I learned that you can create objects that you can't delete in Azure. So I'm kind of screwed. Global admins also have the ability to give themselves a privilege called User Access Administrator in Azure RM for any subscription that trusts that tenant. So the subscription to tenant relationship is absolutely not a trust boundary because the global admins can give themselves access into those subs. So we own everything. We own the entire tenant. What that means is that while seen in isolation, for example, Service Principal D having this MS Graph app role assignment, that may be legitimately configured for some kind of DevOps business process. So you have automation that you need to create, give privilege to service principals, delete them, do some kind of business process, whatever. So this is a legitimate configuration that people do. Also, having a service principal that can create other service principals, totally legitimate thing for like DevOps reasons. Also, having managed identity assignments. This is very common. Azure admins do this all the time. It is just a building block in Azure to let you build your environment so that it serves the business, right? So seen in isolation, these individual things might be seen as best practice or least privilege or this gets to the point of like list-based thinking, where you look at the list of who can grant the global admin role and you stop there. So that's like list-based thinking, where you're just auditing the list of who has a certain privilege without understanding who can take control of that principle, who can take control of those principles, etc. So formed together, these discrete configurations chain together to create an attack path that, as we saw, starts off with no access into the Azure AD tenant and escalates all the way up into global admin. When you start doing your Azure pen test and you start looking for stuff like this, you're going to find it all the time. How bad can this get? So here's an example of somebody trying to do like tiered administration, or whatever the new phrase is that Microsoft uses. Enterprise access model, yeah. Where they're trying to have like, here's my tier 0 subscription, here's my tier 1 subscription, my tier 2 subscription. So I have like all this different hierarchy that like everything under this sub is tier 0, everything under this resource group is tier 0, whatever. But given certain configurations, which emerge all the time, this like environment can change from a collection of discrete control relationships, managed identity assignments, and hierarchy, and it can turn into a spiraling attack path of death. So this can get very, very, very bad. Not to mention that we're just looking here at the confines of the tenant security boundary, but there's no reason that a foreign principal couldn't have one of these privileges, or the other way around. One of these service principals could have privilege in a foreign Azure tenant. So forget about chaining together things within a tenant. Now you're talking about chaining IDP instances, and that's pretty terrifying to me. Okay, so what can we do about this? It's not all doom and gloom, I promise you. And I think we're right on time. All right, so we're going to look at a couple things with defending Azure with BloodHound or with graphs. Graphs give you a clarity of control that you, in my opinion, cannot get from the built-in tooling, especially if you look at like ADUC or the security descriptor GUI in Windows. It's a nightmare to try to analyze. So in the BloodHound GUI, let's look at an example. We're going to look up this VM called Win 2019-002, and we'll click on that, and then that will show us the computer node in the BloodHound GUI. And there's all kinds of really cool stuff that we can look at for that VM. One of those is down at the very bottom, the inbound object control. So that means who has control of this object. If we click on that, we'll see that there are 3 different objects that have explicit control of that VM. So this on-prem user, this Azure user, and this service principal, they all have the contributor role against the VM. If you're a contributor against a VM, you can get privileged command execution on the VM. But what about beyond that? If we look beyond that, we can see there's also a security group that has this role assignment. So it has the owner role against the VM. And there are going to be principals within that security group that, through security group delegation, also have control of the VM. So already we can very easily tell visually who has control of this VM. A question that should be very, very simple to answer with the built-in tooling, but is not. What we can also do is go even further beyond who has control of this thing immediately by discovering attack paths that target some kind of object. So for example, if we right-click on the VM and we click shortest paths to here, this is going to run a query that will find all of the attack paths, or let me say that again. It's going to find all the nodes in the database that have at least one attack path against that VM. And it'll find the shortest path from everything to it. So that will visualize something like this. And so if you are the owner of this VM and you want to understand what is the exposure to this VM from everywhere outside of the subscription or the resource group that this thing lives in, this is what you can do. And what you'll discover is what we were looking at before, that the tenant itself is the security boundary, not the subscription. So anybody with control of the tenant also has control of the VM. That's pretty obvious, I think. But then as you start to map out foreign identities and you start to map out the foreign IDPs and the control relationships in there, you can start to find attack paths that start in, let's say, Fabricam and wind up in Contoso, your VM in Contoso. Is everybody familiar with those terms? Okay. Or like, where's Jesse? Like, where'd you go? Yeah, it's like UW and Wazoo, right? Like what a disaster that would be. All right, now let's talk about a concept called attack path management. So is everybody familiar with the term like tier 0, like tiered administration, enterprise security model, or whatever that was? I don't know. Obviously, I am not. So earlier we had the global admin role. The global admin role is inarguably a tier 0 role. Everyone would agree with that. So that thing belongs within a set of objects that we can collectively call tier 0. Anything in tier 0 should have control of everything else in tier 0. That's the deal, is if you're tier 0, you control everything, including everything in tier 0. Anything outside of tier 0 that has control of something in tier 0, we would call that a tiering violation. And this is something that people tried to solve for a very long time with like Red Forest or ESAE or whatever. Has anybody in this room ever tried to deploy Red Forest or ESAE? Like it's incredibly difficult to set up in the first place, and then it works for about a week and then it crumbles. Like, yeah. So, like I was saying before though, this service principal that has this privilege, there are other things that control that service principal. And so these attack paths start to emerge. So let's just say that like there's 3 things that control that service principal. And for each of those 3 things, let's say there are 3 things that control those things. And for those things, there's 3 things that control all those things. Very quickly, you can start to see what the impact of that connection actually is. And I would even say that that tiering violation is bad, but only the context given to us by a graph reveals how bad that actually is. So what can you do about this? Well, you can get rid of that connection but that might betray the business requirements. So we can extend our definition of what tier 0 is, and we can include that service principal in that set of tier 0. And then we can agree that this service principal is tier 0, it has control of everything, and that's okay. That's by design, we accept that, and we can monitor that thing, whatever. Now you have 3 tiering violations, which you can get rid of. Like there are mechanisms for controlling for specific privileges against other service principals, but in Azure that gets really, really hard to do. It gets very, very difficult to do and even harder to audit. In the BloodHound GUI, if we find the Azure tenant, we can click on the inbound control for that tenant and find everybody who has explicit control of the tenant, or in other words, everybody who has some kind of tier 0 privilege in the tenant. So this is going to be anybody who is a global admin or anybody who can promote themselves to global admin. Same with privileged role admin, because that role can promote itself to global admin. And privileged authentication admin, because that role lets you reset the passwords of anybody who has those 2 other roles. Additionally, it's any principal that has the MS Graph app role assignment of role management.readwrite.directory, app role assignment.readwrite.all, and I think like 1 or 2 more. Can't remember off the top of my head. So anybody who has one of those app role assignments is going to be tier 0 because they can promote themselves to global admin. Then what you can do is you can start to trim some of those privileges. So let's say, who do we want to pick on? Let's pick on Jeff Dimmick. Probably the worst person I've ever met in my life. So Jeff Dimmick has the global admin role against the tenant. Not only that, but like because his user is showing up in green, it's actually an on-prem user who has that role activated. So maybe we can look at that. We can say, does Jeff actually need this? Additionally, we could also look at the logs in Azure, which are kind of hit or miss, but we can look at the logs in Azure and see, like, is that principal actually doing anything that requires that level of privilege? And I think it'd be really cool if somebody like automated that kind of analysis. I think that'd be really neat. And then we can cut that off. Or for the other objects, let's say Rob Lint, probably the best person I've ever met. So Rob, he's also a global admin, and we say, yes, he needs that. That's legitimate. Like maybe he's the only person who needs that. We can keep that. And then we can analyze the inbound relationships against Rob. And we can understand, like, we accept Rob into tier 0. Let's see, like, who has control of Rob? With Azure user objects, that's a lot of that work has actually already been done for you by Microsoft because of how the password reset system works in Azure. It's actually really, really cool. So a better example is going to be like this My Test app service principal. That thing is going to have an app registration associated with it, or it might have an Azure resource associated with it as a managed identity, like we saw in the attack path earlier. So we can decide, does that service principal need to be a global admin or not? Maybe you decide yes. Then look at the inbound control against that service principal and start to do that kind of 2 degree, 3 degree, 4 degree separation analysis to find where can you actually cut out the configuration. Okay, we are pretty far ahead. So let's do a conclusion and then we'll have time for questions. Well, plenty of time for questions. And then I also have stickers up here to hand out if you would like a sticker. And also, if anybody in this room has ever submitted a PR to the FOSS GitHub project, I have a special thing for you too. So let's wrap this up. Here is the attack path that we walked through earlier. So there's a very specific thing that I want to say about this. In Azure or in any IDP, like an AWS account or an Active Directory forest, there is a trust boundary around that IDP instance. So in Azure, If you control the tenant, you control everything within that boundary and nothing outside of it. You can change that so that external identities get access into your tenant, and vice versa. You can change it so that your identities get access into other tenants. And so most of the time, when you're going to configure that, you do that with some kind of federated trust relationship. So maybe you're doing this with ADFS, maybe you're doing this with Azure Active Directory Sync. But those explicit trust relationships in Azure have to be created with the highest level of privilege. So like not just anybody in an Azure tenant can say, we trust this other IDP and we give users in that IDP instance access to our resources. You can't do that without being like a global admin or the federated identity administrator role, I think it's called. So that's good. And you wouldn't want that trust boundary to be violated except by, very high level, very high privilege users, okay? There is another kind of trust. So what I just described, I would call explicit trust. There's another kind of trust that can exist. In our attack path demo here, we're looking at the GitHub organization, which is let's call that a foreign IDP. And it has this attack path into our Azure tenant. The trust relationship that bridges that gap is the OIDC connection. The OIDC connection can be created by anybody with control of that service principal A. You do not need to be a global admin to do this. You don't need to be any kind of high-level admin. You just need basically write access, I would say, to service principal A to create what is effectively an IDP trust. And the first kind of trust we talked about was explicit trust. I would call this emergent IDP trust. And this is a very dangerous kind of trust because it doesn't require a high level of privilege in order to configure. Once it is configured, we have basically said this tenant will trust that GitHub organization to validate the identity of this service principal. And auditing for these kind of emergent trust enabling connections is really tough. It's really, really tough to audit for these connections. Also, the kinds of configurations that can create this emergent trust are still being studied. They're still being understood. So today, Azure admins are setting up their environments. They're doing things like setting up DevOps pipelines, like CI/CD and all this kind of stuff, like doing all this like really cool stuff and building really cool things. They are creating attack paths right now, today. So they are creating these attack paths that if things don't change and if defenders don't start thinking in terms of a graph and seeing objects in the context of those attack paths, we're going to wind up today building what we're going to be talking about in 20 years from now, talking about like responder for Azure or Mimikatz for Azure or whatever. So it's crucial that admins understand this today and find, fix, and prevent the creation of these things going forward. All right, that's it. Thank you. This is my contact info. There's just some helpful links. And yeah, I guess we've got time for questions if there are any. And if there aren't any, I've got stickers up here that you can have.
I wanted to go back to your earlier point about the cyclical offensive perspective.
Yeah.
Defensive perspective.
Yeah.
And the reason is I've seen a lot of offensive-minded people kind of say we need to burn down AD to the ground.
Yep.
Kind of an unfortunate recommendation. Kind of it sounds like it's so hopeless. What would And we've seen like CISA come out and you could PwC like saying, "Oh, use BloodHound as a defender."
Sure. Yep. Yeah.
What would your main recommendation be for people like from a defender perspective? If we can recommend, like if offensive people can recommend something.
Yeah.
Defenders do tomorrow.
So his question is like talking about that red team cycle of tail chasing that a lot of pen test shops or IT audit or whatever, their recommendation is going to be like burn AD to the ground and start over. Obviously, most organizations are not going to do that, and it also doesn't solve the underlying issue. So the question was, what is my recommendation for organizations as far as how to make some progress here without having to burn everything to the ground? You mentioned that PwC and DHS have recommended that organizations use FOSS BloodHound in order to analyze and mitigate attack paths. I would echo that recommendation. So FOSS BloodHound is free, as FOSS implies. The thing itself is not really built for defenders, it's built for attackers, but you can definitely get a lot of defensive wins. And I've got a blog post written up about BloodHound versus ransomware and how to make those wins. So I would echo that recommendation. I guess what I would also recommend people do is understand that the other IDPs don't have this problem solved, and that burning it to the ground and rebuilding it could kind of be the same as abandoning on-prem AD in favor of Azure AD, but that's going to be out of the frying pan into the fryer. So I guess in general, my philosophical advice would be lean into the problems that we are seeing and don't be defeated by them, but see them as I think there's a Stoic philosophy quote that's what stands in the way is the way. So there's this obstacle of Active Directory attack paths seeming impossible to fix. Let's fix that. That's our way forward, I think. Yeah.
Is the slide deck in the references that you posted on your first slide?
This slide deck?
Yeah.
Yeah. Let me go back to the front. There's a bit.ly link that'll take you right to it.
Yeah.
There you go.
But a question online, could you go over the user access property that a global admin can use to go from one sub to another? Is that something you can do?
Oh,
easily?
sure, yeah. How do I want to do that? I don't feel very comfortable sharing my Azure portal GUI right now, but if you log into the Azure portal as a global admin, search for or click on Azure Active Directory, that'll take you to the tenant object view. On the left, there is an item called Properties for the tenant. Click that, scroll all the way to the bottom. There is a toggle that by default is no. You change that toggle to yes, and the toggle basically says this user is allowed to manage subscriptions. Toggle that to yes, hit save back at the top. And then what that actually does is at the root management group, it applies the user access administrator role for that user at that level, which then inherits down to everything. So that's how that works. It's a feature of Azure. It's not a security bypass. It's just, I wouldn't even call it a roadblock. It's an open door.
That was amazing. I saw the whole UI in my head as you were describing. That was fantastic.
Good. Yeah.
So we have a lot of clients that are actively migrating a lot of things to Azure or whatever, but it's nascent stages, and it's we do a lot of banks, like you said,
yeah,
and stuff like that. So it's they might have Microsoft 365 and Azure and the UX sign up for that or whatever, but they don't have VMs. There are a lot of subscriptions going on.
Yeah.
Are there still a lot of valid attack paths that Azure House can help, even when they're not using those types of resources within Azure?
Yeah. So the question is, if you're not if I could restate the question, if you're only using the Azure AD service and you're not using the Azure Resource Manager service, are there attack paths that can emerge? The answer is yes. There are certainly more that emerge when you have Azure RM and you have that, populated with things. But at the Azure AD level, there are attack paths that can emerge, and they have, I would say 99% of the time, they are abusing service principals, not users, because of the fantastic password reset architecture. I say that sounded sarcastic, but I actually do believe it's actually a fantastic password reset architecture. The users are a little harder to exploit in Azure, outside of stealing tokens. I mean, that's still reliable. But service principals, that's where I see the attack paths traversing through app role assignments with MS Graph, the explicit control relationships between service principals, and then service principals being granted roles such as Cloud App Admin that then apply to all other service principals and app registration objects. And then at that level, you also do have devices, but I don't see that being used a whole lot, but you can definitely have attack paths that traverse a device and then back up into the tenant. I think maybe time for one more question.
We have 1 minute.
1 minute, right there.
Really quick question about the detection possibilities for attaching this downline. C and D seems to have events that occur that might be detectable or something we can look at from a learning perspective. I wanted to see if there's anything to think about from a detection and learning perspective.
Yeah.
So adding the secret and granting those seem like things that would be conceivably audible.
Yeah.
Or create an event that could be then triggered on for learning.
Totally. Yeah. So his question was, are there detection opportunities for the abuse actions that we did with service principals C and D? The answer is yes. So there are by default logs turned on for the abuses or the abuse actions that we talked about here. So for a new app role assignment, that generates a log. For a new secret being created or a cert or whatever for a service principal, that is logged. So I would say that's great for logging. Not only is an adversary operating in our tenant, I think it's great for that, but also I think it's great for, we have our security posture in such a really good state. Let me know if that posture degrades. And so like if an unexpected service principal all of a sudden has privilege, that may not be an adversary. That may be, your friend Azure admin who set that up, didn't understand the consequences, and then you can alert on that and you can do something about it.
Cool. Thank you.
Thank you so much, Andy. Really appreciate that.